Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Muhammad Raji Muhammad Sadiq, and in this video, I will be presenting my assignment, which is based on data analysis using Weka for the course BJT 4223 Data Mining. In this assignment, we are asked to use the Weka tool to analyze data, to perform data mining, various data mining tasks, including data processing, feature selection, classification, prediction, model evaluation, association rule mining, and various other data mining processes. So, inshallah, without wasting any time, I'm going to dive in to the video right away. So, first of all, I would like to walk you through my data. So, this here is my data, which is shown here right here. It has 1, 2, 3, 4, 5 attributes. So we have the weather attribute, the temperature attribute, the humidity attribute, the wind attribute, and the play attribute. So as we're looking through the data, we can see that we have some missing values here on the play um on the play column. We have 1, 2, 3, 4, 5, 6, 7 missing values. So how do we how do we manage these missing values? So here I have used the replace missing values filter. So this filter will replace all missing values for nominal and numeric attributes in a dataset with modes and means from the training data. So I have solved the problem of the missing values by representing them with mean and modes from the same column. So as you can see, I have visualized the relationship between each columns with the target attribute, which is the play attribute. So first, we can see for weather, we have these bar charts here. For the temperature, we have these bar charts here. For the humidity, we have these bar charts here. For wind, we also have their respective bar charts. And for the final attribute, which is the target attribute, we have the play attribute, which has the bar charts here. So in this data set, the target attribute is play, while the independent attributes would be the weather, the temperature, the humidity, and the wind, which is going to be used to predict the value of play. Now I'll go to the next part, which is attribute selection. So in this part, we use the CFS, subset eval, and information gain attribute evaluators. So for the CFS subset eval, we have this result here after applying it to the data. So you can see the evaluation mode, evaluate on all training data, search method, best first search. So it is a best first search method. So, and then we can see that the selected attributes are 1, 3, 4. What is 1, 3, 4? Weather, humidity, and wind. So these are the selected attributes by the best first search algorithm using the CFS subset eval attributes evaluator. Now to the next one, which is the information gain. For the information gain, it gives us a simple result right here, which is this, and its attributes are 5. Choose the weather, the temperature, the humidity, the wind, and play. So this shows that temperature is less useful for prediction according to the CFS subset eval. Now to the next part of the video, which is classification. So for the classification, okay. So for the classification, we start with decision trees. So for decision trees, we can see here that we have 6 number of leaves and 10 size of the tree. So it starts by splitting. We use 66% of our training data and remaining for testing. So in In Weka, we use the J4 prone tree because this is what is available that supports the decision tree. So it says whether it's sunny, it analyzes the data, and then here we have the results. So we have the mean squared error, the root mean squared error, the relative absolute error, and we can see that it is actually accurate with an accuracy of 93.75% and inaccuracy of 6.25%. So the next prediction to the next algorithm we use, which is the prediction, we used k-means clustering. So for the k-means clustering, we use the same 66% of the data, and then we test different kinds of k's for k is equal to 1, 2, 3, 4, and 5. So for k is equal to 1, you can see that it has a 96.875% accuracy, which is the highest. For k is equal to 2, we have 84.375. For k is equal to 3, we have 84.375 as well. K is equal to 4 and k is equal to 5, we have the same accuracy, which is 84.375. This shows that what k is equal to 1 is the most accurate method we can use to predict the data, then followed by decision tree, which is 93.75. Then followed by k is equal to 2, 3, 4, and 5. Now to the next part, which is the clustering. For the cluster, we use the simple k-means as well. And here we can see the cluster centroids for the full data for 0 and for 1. Now to the next part, we have the association rule mining, which is an important part actually, and it actually, brings everything we've been doing together to interrelate with themselves. So the a priori algorithm, what I can see is that the a priori algorithm has found strong rules like overcast, and play. When overcast is in the same row as play, it will be resulting to yes with a high confidence, which is close to 100%. And these rules were very meaningful and support decision making. Imagine you want to play on a day. One day you want to play and then you really don't know if you should play or not. So if you could get hands on these algorithms, it will be highly accurate and it might help you make decisions sometimes. So my conclusion is that the best model was KNN. But before that, I want to do a model evaluation. So here I have created a a table that actually summarizes everything. So we can see from here the model evaluations. So now we can see the first model type, classification, prediction, and prediction again, but we are going to see why it's prediction twice. So here we have the algorithm, right? For the first algorithm, for the classification, we have decision tree using the J48. Then the next prediction, we have K nearest neighbor, K is equal to 1, and K nearest neighbor for K is equal to 2, 3, 4, and 5. So for decision tree, we have the accuracy of 93.75%. And then for the prediction, we have 96.875%, which is the highest accuracy we've seen here. And for KNN is equal to 2 to 5, we have 84.375, which is the lowest accuracy we've seen here. So the precision is right here with prediction KNN is equal to 1, having the highest again, followed by classification, decision tree, and followed by KNN is equal to 2, 3, 4, and 5. For the recall, we have K nearest neighbor 1 with the highest recall, with the highest average recall, followed by classification, followed by prediction. K is equal to 2 to 5. For the F1 score again, we still have the same result. For prediction, K nearest neighbor K is equal to 1. We have it again as having the highest average F1 score with 0.968, followed by classification 0.933, and K is equal to 2 to 5, K nearest neighbor, which is having 0.807. So what can we actually conclude with these values? We can see that the best model to make the decision whether to play or not is the k nearest neighbor. The k nearest neighbor with k is equal to 1. Because it is highly accurate, it has a high precision, it has the highest average precision, has the highest average recall, and it has the highest F1 score. And because of this, it is the most accurate and most reliable model type that we can use in this case. But let's not forget that decision tree is also important, as it helps us, add value to the results. It helps us find hidden structures in the data, and sometimes we can actually use both together to rub minds and see what could actually happen. So this will be the end of my presentation, and I hope you have enjoyed and learned some things, one or two things about this prediction model and how they are used with the Worker tool, which is a very amazing tool, by the way. And I hope that you can gain a lot of things from my video. Thank you so much, Dr. Fatima Noni, and Assalamu alaikum wa rahmatullahi wa barakatuh.